Hi Lars, good to see you again.
Hey, Young. Thank you.
Thanks for joining the Next Wave Speaker Series.
My pleasure.
And we're here at the Autonomous Conference where we try to advance technology, collaboration, even the policy making to make the machines and man interaction better than the way it had been.
Building the world that anticipates and automates.
Exactly. So before diving into our discussion, Lars, I'd like to introduce audience who you are. So Lars, you are Executive Vice President, Chief Technology Officer for NXP, which is a major semiconductor company that are enabling all of our products and especially industrial products better. And as a CTO, you're responsible for managing new business activities and R&D in automotive, Industrial 4.0, IoT, mobile connectivity, and infrastructure-focused markets.
Yes.
Right? You're also on the board of nonprofit that I co-founded with Bill Tai, Extreme Tech Challenge, which is really trying to help startups and corporations to collaborate to increase the acceleration of innovation to deploy for the UN 17 sustainability projects. And I thank you for that.
Doing tech for good, yeah. Very close to my heart. And I mean, we have moved a lot in the past, and I think there's so much more to come, yeah.
Absolutely right. Innovation has no limit, right? Exactly. Yeah. So let's start with your background. Could you tell audience a bit about how you got to where you are?
Well, honestly, a lot with passion, very little with planning. So I grew up in the central western Germany, very rural area. My parents are primary school teachers, and I decided after my high school to study physics. 2 years later, I also started studying medicine. So in combination.
Medicine?
I stopped medicine after 3 years again because I was close to my diploma then and got a job offered in Siemens Semiconductors in these days. So moved to Munich. But yeah, that was the start of a great combination. I wanted to build medical systems based on semiconductors, and how I moved then into semiconductors was basically the first step there. Did my MBA later at London Business School, so that combination of natural sciences and being able to handle finance, that was of course a good basis. And I then moved from Siemens Semiconductors Infineon to Siemens Video and Continental, so an automotive tier 1 building navigation systems, car telematic, robotics in the first stages, and from there moved into one of the big automotive chip suppliers, NXP. So the former Philips Semiconductors, that then later merged with the former Motorola Semiconductors. So NXP today is basically a mix of the Philips culture, the Motorola culture, but of course now one of the key semiconductor players for smart connected devices or little robots.
Right. I mean, if you think about history, right? The industry, semiconductor industry, really shaped by those companies.
Yeah, no, absolutely. And I mean, a lot, of course, started there from the Eindhoven or from the US, Austin and Phoenix main hubs, mainly for us, which we still have today. If you pedal back in history, from moon landers to smart lighting, smart TV, of course, a lot of those innovations, DVD systems came out of those mother companies up to mobile phones and modern technology. Yeah.
So, you know, it's funny, obviously semiconductor is a very critical industry. Yes. I mean, Silicon Valley, it really symbolized the Silicon Valley was Semiconductor Valley, right? Yes. So that was the importance of the 60s and 70s. And then we kind of forgot about semiconductor because if we assumed everything is given. And I remember a couple of years ago, I was talking with a CEO, I'm not going to say who, because you will know, of a major German auto industry. And he said, young son, I never thought about chips, because I just thought all chips are there and they'll be given. But with supply chain disruption, yes. Now I have to learn about chips all over, and I realized there are so many different chips.
Yeah, there was of course a very strange dynamics. I mean, until recently, a lot of people thought that the semiconductor industry did not perform and we let the industry down. But compared to pre-pandemics to last year, we have shipped as an industry 1.5 times the chip volume compared to 2019. Now, The issue was that the semiconductor increase in those smart rolling robots increased so much that we would have needed to double the volume. So it was not exactly a semiconductor shortage, but it was an undersupply compared to the demand. And that led, of course, to a lot of people waking up and saying, hey, why can't we quickly get semiconductors? And then only they understood that it takes 6 months to produce a semiconductor and that it takes 4 years to build another factory.
Exactly. So it's very
a lot of people got to know now suddenly this supply chain.
So the CEO said, you know, I guess not all chips are built equal.
No. No, indeed. No, I mean, we got very funny questions in the beginning. Yeah, Lars, if the one factory has 28 nanometers, so this is the transistor dimension, exactly. 28 nanometer technology, and the other one has it, and the one is overloaded, and the other one still has capacity, why don't you move from A to B? And I really had to come back with the anecdote saying, hey, we are all making material for breakfast. The one is making sausage, and the other one is making marmalade. Yeah. Try to make sausage in a marmalade factory. So the recipes are so differently that even for the same transistor dimensions, it does not match. But of course, you have very, very different technology for precision analog measurement of battery cells compared to tiny little compute systems in your mobile phone where you have 4 billion transistors on a chip. Yeah.
It's very, very interesting. So I had a weekly call with him about supply chain crisis of chips. And he really understood that not all chips are created equal. In fact, you cannot ship from one plant to the other. And also, I think he realized that industry was using really old legacy product with a very long life cycle expectations. Frankly, you know, there's a lot of advanced chips they could design in, but they didn't have to in the past. But now I think they're realizing if they want to keep up with industrial development, you have to use the latest chips.
What you're going to see at the moment is, of course, that a lot of car makers are changing at the same point in time their architecture. So in other words, they are switching from combustion engines, for example, into electric powertrains. And with that, they are not only changing the powertrain, but they are changing the entire vehicle architecture to a more modern level. And these more modern levels have a factor of 10 more silicon. And therefore, it's not only like a little tiny tweak, as we had it in the past, you get a better radio or a HVAC system, which is very, very tiny changes, but the entire industry is suddenly going into new car architectures with 10 times more.
Right. So often we actually use the analogy because as you know, when we acquired Harman, when I was at Samsung, the key assumption was that much of smartphone technology can apply to automobiles. The connectivity, the electrification, the sensors and cameras and AI, all those things. And I think what that means is you just need a lot more content for chips processing power.
You have to exactly understand how you do that. So I think it's a very, very good example to have cellular connectivity in your car. I mean, the car market in itself, just 180 million devices per year, is so small that no one would develop a mobile phone connectivity chip, 5G, just for a vehicle. So you have to make sure that your consumer electronics can come in, but that this cannot impact the powertrain that has to be totally failure-free, has to run under all circumstances, has to be highly safe and highly robust. And for there, you need special semiconductors and special system design. So building these robots requires a very conscious choice how you architect and how you decompartmentalize the different challenges. So living in temperature domains between minus 20 and 60 degrees centigrade for the cellular part is fully okay, but at your brakes, you have temperatures up to 150, 200 degrees centigrade, which is a huge challenge for a semiconductor. So you cannot have all requirements in all corners, and you have to go for these mission profiles. And that's a lot of the challenge, of course, that you don't get only semiconductors off the shelf.
Exactly. So what we are really talking about is industrial requirements, which is much different than consumer requirements. Because also consumers, you know, let's be honest, usually the mobile phones turnover every 3 years, people change. So it's more throwaway culture, which is not the best thing for recycling perspective. But it is what it is. Whereas industrial products have to last much longer because it has a safety implication.
And average car lifetime is 10 years plus, right?
Exactly.
I mean, so from that angle, an interesting challenge also to the semiconductor industry, because these architectures are required now, if they are very heavily electronics based, to be upgradable at least for 10 to 15 years, which was, of course, in the past. I mean, you have a piece of mechanics, sort of 20 years ago, a car was mainly mechanical engineering. Today, it's mainly 95% of all innovation is electrical engineering. But then, of course, the planning ahead, have safe and secure upgradable systems, is not exactly in the DNA of the old school car makers. So they have to acquire very, very new features.
So a lot of cultural changes are required for given the new reality, right?
Development-wise, I would really call it disruption. For the end user, okay, it's a very comfortable car, yeah. But in development and in the development processes, mega change.
So you've been observing industry for a long time, and you also spend time in auto industry. So given one of the key interesting subjects is this idea of autonomous driving. And this is why we are here as well, which requires probably the most complex and most sophisticated software, hardware, sensing have to come together. And in a safe manner, because we're dealing with life. So tell me about what you see. I mean, first of all, let me ask you a very bold question. When do you think we'll see autonomous driving out there?
And the answer is, it depends. Because let me
okay.
tell you what I mean. So when I was at CES in 2018, journalists were asking, of course, when will autonomous cars come to the market? Right. And what do you think about autonomy? And what these journalists had in mind is that very, very soon, the cars are more intelligent and more emotional than the driver, have no steering wheel anymore, and our kids can drive to the kindergarten without parents. Yeah? So these type of things. That mission profile is far out. But for people like me or like my dad, we are living 500 kilometers away from each other, and my dad is in the mid-80s. He wants to visit me. So he has a 10-kilometer drive to the highway, and I have a 10-kilometer drive to the highway. So how cool is it for him to drive 10 kilometers, press a button, and on the highway have a highway autopilot, and after 480 kilometers on that highway, the car says, hey, can you please drive the last 10 kilometers manual again? Right. This is what happens already. We have cars out there in the market that can do that, well, in the higher segment. So it takes a couple of years until we have them in the affordable segment. Right. But that is car reality today. The other part, steering wheel-free driving, I'm not that convinced that this is happening soon. Okay. Also because the purchasing need, the willingness to buy those cars is not in the mass market. The mass market is what I had described with the highway.
So term that we use in the industry, right? There's a level 1, level 2, level 3, level 4, level 5. This is, we talk about level 3 minus, right?
So somewhere around
somewhere there. It's hard to define.
Exactly.
The point is that driver can still take over in case of safety.
And
however,
critical areas, he has to take over in low complexity areas. So low complexity means no side traffic, no toys on the road.
Like highway.
For example, there the car tank.
And there, in case of emergency, the machine can be able to safely park aside.
There will be different safety mechanisms. Today in our ADAS cars, so driver-assisted cars, we have that already. If you don't have the wheels regularly on the hands on the wheel, if you are not monitored with drowsiness monitors and so on, the car will signal you, will start beeping, maybe the wheel is vibrating, and then it will slow down.
Right, exactly. Yeah, so I have experience with Tesla, and of course the experience with other vehicles, and it's coming into as a part of assistant driving, I would call. And hopefully, you're right, highway driving can be really boring. And not very safe because of drowsiness and others.
It gets worse. Just imagine these typical moments in the morning. Yeah, you are in a traffic jam, stop and go, and you are already deeply in the day and in your schedule. And this is where the stupid accidents happen, where you are at a speed of 20 miles, you're bumping in the guy in front of you because you were processing different things.
Else.
And there we have already all technology in the industry, adaptive cruise control, radar systems, and so on. So that's solved.
Okay, so Elon Musk promised of 2019 at the CES. I remember he said full autonomous cars will show up 2019. Maybe it'll take some time, but we do have some in-between versions that are possibilities.
Yes, and I mean the magic is not that we have cars that can, under normal circumstances, drive autonomously. I mean, this is what you can see. But you do not want to have cars that are only 98% correct and 2% goes wrong, because you create fatalities. Right?
Yeah. So tell me about your view of what the industry need to do to collaborate to create certain principle and practice that are predictable among in the industry, because no car company can just do it alone, right? Because it requires a multi-party collaboration, standardization. So I'd like to hear your perspective on this.
What happens, what we see now, and this takes time, and this is why we don't have these cars yet on the road, but there is a lot of architectural discussions. How can you delayer these complex tasks? When do you need a creative AI system, a smart brain? And how often can you drive on deterministic rules? And how do you overlook whether an AI system is doing wrong things that you can filter out with deterministic rules? That requires a lot of architecture discussions. It requires a lot of careful definition, how you have these fallback mechanisms, functional safety wise in the vehicle. And it is, I would say in the widest sense, a lot of research and development of robot building. And what I mean with that is the following. In 2018, the understanding of the public was that there is an AI system that is just observing how a driver drives, and with a lot of driving data, that system knows how to drive and drives. But this is not how we humans are driving, because we are passing a driving test, we are making a driving license, and we are hardcore learning the rules. So in Europe, you drive on the right side of the road. You are not going diagonally over crossroads. You are stopping at the right traffic light or at a stop sign. So this is rules that you can program into the machine. And if your AI system would get overly creative and say, I need to go to the left and I go straight over the crossroads, these rules need to interfere and say, sorry, that is forbidden. This is what every driver is doing. Where you need the creativity in that system is when your rule-based system, camera, laser scanner, radar, they all say there is an obstacle, an obstacle, an obstacle in front of us. You stop, and then you need to find out what that is. It's a car in front of me. Okay, now, do I understand what that car is doing? Is this car the end of a traffic jam? Or is this car just parking? If it is, and now the AI needs to come in because it needs to find out what is my exit strategy, like our main brain. What is our exit strategy? If it's the end of a traffic jam, then taking over and get going is a very bad idea. If it's just parking, then waiting for 4 hours is equally bad idea. And you have to delayer that. You have to understand each of these tasks, the deterministic ones, the creative ones, and you have to apply them in the right way. So it's not just like you throw an AI accelerator in, get going, and it is all solved.
Clearly, we are now in a major hype cycle of AI, and ChatGPT is in the top of the cycle. And applying ChatGPT in the safety environment like this could create chaos.
Totally. So I mean, my favorite slogan is you don't want to be driven by ChatGPT, because it is fantastic and great, and it surprises you what it can generate in terms of newspaper articles, for example. But you need to really understand, sometimes it takes a detour and writes fake news. And you don't want to have something that drives fake and off the road. So especially there, you have to have very good, should I say, co-pilots that are doing the consistency checking. And building these type of systems, having this great creativity and generative AI, what do I do behind the car, traffic jam or not? Plus, okay, how then rule-based, in a safe way, I overtake when I think I should do that. These are the combinations.
So Lars, do you think the industry need to collaborate in agreeing on certain principles and approach?
Absolutely, yes. So what, point one, there is no one today that I know that is combining all of these requirements that I had just said. 5 years ago, people were even looking puzzled when we said we have to research on those things, how safety and security and AI systems work hand in hand. So there is a lot of research going on, a lot of value capture. But as always, for these type of systems, I mean, you are way too slow if you try to do it all yourself. Plus, these devices get very, very software heavy. Yes. So autonomous vehicles could easily have between 500 million and 1 billion lines of code if you take all the control units in these cars. This is huge. You have a lot of hidden bugs in the software alone, not only in the hardware. So if you want to test, if you want to, in a robust way, bring these rolling robots onto the road, that is a Herculean task, and no one for sure can afford to do that. And therefore we have to scale differently.
In a way, it's an opportunity too for IT perspective.
It's value creation in the market. So I mean, if you look at it from that way, I mean, like every innovation was a capability of value creation. This one is one as well.
But the other thing is that, you know, the machines with AI, the more data you provide, the faster it's going to run, right? So the pace of innovation across geography changes, right? If you are Chinese companies, as you know, there are 500 car companies, they all came up. Now they are consolidating a bit, and the new guys are coming in, like BYD coming in top, and actually people like Huawei is now coming in to the car industry as well. So as the technology and battery companies out there coming in, the model that we see at different geography has a different implication for speed of innovation. Could you comment on that?
Yeah, I mean, what you see is, of course, cars, modern cars will be very, very differently built than the cars of 20 years ago. So cars of 20 years ago, I mean, someone, Daimler and Maybach, 140 years ago, took a horse carriage and put a combustion engine in. And from there was this evolutionary path, and okay, you do exhaust gas regulation and you have less emissions and so on. But this is a very, very clear starting point there, and it's an optimization of a certain piece of technology. Now you talk about rolling robots, and suddenly others have a value proposition. IT companies say, hey, I know how to build IT systems, and whether they have wheels or not. I know how to manage battery systems. I know how to deal with much less moving pieces, but much more electronics in there. And the big tech players from the IT industry, they all start looking into rolling robots now. And of course, they are threatening the incumbents. I mean, this is exactly what you're seeing at the moment. And Shakeout will, of course, be not everyone who thinks.
So, innovator's dilemma, right? It's classic. When the new technology comes in, whether it's an AI, whether it's ADAS technologies, it changes the rules of the game. And the newcomers can come in with a lower cost, better performance. But maybe also what's critical here is the fast iterations, which will push the innovation cycle faster, but then that creates new winners and losers, I guess.
No, indeed. I mean, the value that you can bring to the party is, of course, the faster you spin your learning cycles, the more ahead of competition you are. And as you said, in the inventor's dilemma, I mean, the incumbents, they have two chances. Either they change, or they will be changed or extinct. Right. If they are in denial, I mean, a lot of the guys, of course, have now to prove that they are nimble enough to adjust, and not only are resting on the laurels of the inventions of Daimler and Maybach 140 years ago. Right. And that will create shakeout. Consolidation on the one side in the new markets, but also some dinosaurs will leave the ecosystem.
Yeah, you can really see that in electric cars. The market share of electric cars represent a very different kind of player than traditional past. And I'm sure we're just in the beginning of that cycle.
Yes, and I think what we need to do is we need to watch these inflection points. Because today a lot of people say, yeah, electric cars don't make sense for me. I want to have a driving range of 600 kilometers and I don't get that and so on. But if the learning curve, the energy density of batteries continues as it did in the last decade, just 1 decade longer, then suddenly you have cars again that can run 600, 800 miles. At that point in time, you are, as a human being, the weakest part of that chain again. I can drive maybe 500 miles non-stop, best case, and then I need at least 1-2 hours of break. Right. I can recharge again. Yeah. So at that point in time, I will not realize anymore in my normal life pattern, whether I have a fuel-driven or an electric drivetrain, because it does not impact me anymore. It does not limit my driving range and so on. And then, of course, the take rate will swap immediately.
And I have to say, I've been driving electric car for now 7 years, Tesla S and Y. And basically, it's so nice not to smell the gas and not.
Yeah, and you're not at filling stations anymore.
Exactly.
Right? I mean,
yeah.
You're at home.
Yeah, I'm just plug in at night, and that is very convenient way of living.
Yeah, you plug into things, or you charge a mobile phone and car, and in the morning you leave again. Yeah. So for normal driving pattern, this problem is already solved. And I think what you will see is in the next 4 or 5 years, next 1 or 2 generations of cars.
Which will change, which is also in a way good for NXP, I think, because it takes a lot more components that enabling the electrification.
Battery management, and each of these single cells needs to be managed separately to optimize the battery charging cycles. And each of this separate management requires silicon. So from that angle, very good.
Now, tell me about safety perspective, right? Safety and privacy perspective. Because as we are creating an architecture that are much more centralized, much more connected, it has implication to maybe more efficient architecture, more centralized architecture for safety. But at the same time, it also has a risk that introduced as well. So what are you doing about the safety side around the ADAS architecture you guys are working on?
It has, of course, you have to be conscious of it. Let me be very, very careful. And then it creates gigantic opportunities as well. I give you one old example. My wife is a general practitioner in a medical practice, and of course there is a lot of discussions. Should we store data in encryption modules, so patient data in encryption modules, or is this a threat? Well, very honestly, the threat is that all these old practices have their printouts still in paper. And there, the paper strips are flying around, and modern electronics and modern systems even bring an advantage. If you could hack an entire database and that would be transparent, there's also a significant risk. They have to architect against it. And the same setup we have in vehicles. So saying, okay, if I have a lot of little brains in my vehicle, compute cores, they can observe, of course, each other, what they are doing. I have suddenly co-pilots in my system that can say, hey, wait a second, 3 wheel speed sensors are telling me they are okay, and one is sending totally crazy data. Hey, what do I be? So you get for free redundancy in the system, consistency checks in the system. You only need to build the architecture in a way that you think about it from the beginning. And then fewer ECUs, less wiring harness, less breakable wires and corroding connectors and so on, is in principle exactly the more efficient way going forward. Yeah.
So in a way, if you think about it, it is the future of auto. It's like having industrial servers with wheels on it and batteries. And it's high-speed interconnect, centralized compute.
Like in big compute farms, also certain redundancy.
Right, with
and so on.
sensors.
Yes.
Yeah, exactly. So let's change a little bit about the CHIP Act, which is something that we didn't think about even 5 years ago.
No, that is true. I mean, what you see is over the last 5 years, of course, we had one pandemic with the aforementioned supply shortage that we had. So everyone was trying to understand how mission critical semiconductors are for me and my business, my company. And then, of course, people were looking at, hey, where is the concentration of semiconductor development and semiconductor building? And we have a truly global supply chain. So semiconductor workers are everywhere around the world, but we have a couple of very, very big local players in this globalized world. And for example, in Taiwan, in Korea, and in mainland China, you have a huge amount of the semiconductor making, contract manufacturing. In US and Europe, you have a lot of semiconductor chip development. Now, if by any movements this ecosystem gets disturbed, and the West is not talking to the East anymore, then development and tool supply suffers, and on the other side, what you have is manufacturing is isolated. So in that, the entire industry woke up and said, hey guys, we need to really make this global supply chain and ecosystem, we need to make this truly a global ecosystem and globalize the local players.
Right. So I mean, basically we all spent so many years in semi industry. It was one of the most global industry, right? Well, you can imagine. So you have a design maybe in Eindhoven or in Silicon Valley. We will use the tools that are coming from maybe Cadence and Synopsys, with IP coming from Arm in Cambridge. And then it's manufactured at TSMC or Samsung, and then tested in Taiwan or Malaysia, and then it's consumed in some locations and then shipped to end customers.
Exactly, and the end customer did not understand and did not know at all about this complexity. And I guess most of us in the industry also did not overlook that complexity.
Right. Now with, excuse me, with the pandemic and also increased geopolitical tension, it is clear that globalization now moving to, I think, a global risk optimization, so managing the risk.
So we had really a lot of requests from politicians now over the past years who try to understand how strategically important semiconductors can get. Just imagine entire US or Europe would not be equipped with semiconductors anymore, or entire Asia would not get semiconductor manufacturing equipment anymore from the Western world. I mean, suddenly you can bring this entire machine to a standstill, and most of our customers could not produce anymore their goods 4 weeks, 8 weeks after we stopped this supply chain.
So most audience may not know, but building chips requires an incredible amount of investment. Like Samsung, typical memory fabs will cost at least 10 billion to 20 billion now with smaller geometry, and it takes 2 to 3 years to build it. So,
at least.
At least.
So 3 to 4, I would say, is more reasonable. Yeah.
And then when you have a supply chain interruption, there is no other way to build your end products without chips. It is, in a way, worse than oil. Because oil, you can actually get it other resources, other refineries.
That's maybe one of the key learnings. Why are so many people today, via the CHIPS Acts that you mentioned, looking into front-end manufacturing? Well, there is, of course, also other industries that could have supply issues. Look, for example, at wiring harnesses for the German car industry when the Ukraine war started. Yeah, but you can start sourcing wiring harnesses also from a lot of different countries. And this was a 8-week, 12-week disruption of the supply chain, but and it cost a lot of task forces and logistics hustle and so on. But it was solved after 3 months. Just building a semiconductor from the wafer to the little package takes 6 months. Only building, if you have the capacity. And if you have a capacity issue, moving a factory, no way under.
The other issue people are underestimating is it's not just spending money, right? It is about talent. It's also about the industrial ecosystem, from clean gas to the actually reliable electricity and water. It's not that easy. So I think that the whole world is waking up and saying, wow, we really outsourced. I mean, 80% of all the chips are made in East Asia. If there is a conflict there, we are hosed. So I think that's the realization.
And I mean, just to get this clear, 5 nanometers transistor size, which is not, so there's even smaller technologies these days for digital transistors. But 5 nanometers means that this is a gate length of a transistor of 50 atoms, only 50 atoms. And now, if you impurify them, then the machine, a 4 billion transistor chip, is broken with one impurification there. Now, what we need to make sure is, of course, that these chemicals are super, super clean. So the semiconductor factories are not only sourcing from one supplier only, but from one factory of one supplier in one region. So that is so sensitive, that ecosystem, that, for example, also we had huge issues when we have natural catastrophes like this flooding in Germany 3 years ago.
Or Japan.
Earthquakes and so on, or Fukushima. In each of those cases, you can have very severe disruptions to the supply chain just because you have to swap from one material, same different side of the same supplier, and it is already difficult.
And it gets much more I think, harder now as we are pushing the geometry, which makes it very, very few suppliers that can be able to build the chips in many ways, and that makes it much tougher, difficult discussion. Now, the other side of the equation is also architecture discussion. So there is today one of the most valuable company is NVIDIA. And who would have expected that, right? 10 years, I don't think I'm an industry person, I don't expect it. But without that, you cannot run large language model.
No, indeed. I mean, from a hindsight, so predicting the past, of course, it makes a hell lot of sense, right? I mean, so NVIDIA was very, very focused on one specific product category, and this was graphic cards. And for graphic cards, so for pixel operations, you do a lot of parallel processing. Exactly. And this is what you need for machine learning, AI accelerators. That, of course, then makes sense that you develop your portfolio into that direction and capture a lot of value.
And also have to give kudos to Jensen, investing in his software platform, particularly CUDA, because he needs to enable industry to adopt in gaming and others.
Fully agree.
And I think that thinking was very important, and that's what made them to be where they are. So let's go forward, because clearly industry doesn't want ARM and NVIDIA to run the world, because I spent years at ARM as a supervisory board, so I'm happy that ARM was very successful because they challenged the incumbent Intel in many ways and came underneath with a lower power solution. But the question, I think, is every 20 years, there's a new architecture that comes out.
Yes, and there's, of course, also quite some dynamics on whenever someone becomes a monopolist, there is others shaping up because, or whenever there's geopolitical tension, so whenever there's external force, there is, of course, the rest of the market trying to find alternatives not to be overly exposed.
So let's talk about the role of RISC-V, because you recently have announced, along with several other key European players, and actually even US players as well, to support RISC-V as an architecture that you want to support, along with what you already have. So I think it's interesting how RISC-V is getting a lot of momentum, right? You had Bosch and Infineon, Nordic, and Qualcomm and others are all joining together to advance the RISC-V architecture, which came out of Berkeley.
Yeah, in 2012, I think.
Exactly.
I mean, the mechanism of RISC-V is a little bit like Linux. So where Linus Torvalds from a university at some point...
Another Berkeley product. With a lot of European contribution.
Indeed.
Yeah.
So, I mean, that was basically an ecosystem, and you had operating systems from Microsoft, for example, being by far the biggest market share there. And then you have Unix at some universities, and suddenly an open source ecosystem shapes where everyone can contribute. And this thing gets an enormous momentum because you have all these developers. You don't organize them in a company and you don't organize them commercially. You have all these developers go in open source. And then on top, you have commercial companies again, like Red Hat, SUSE, Ubuntu, that are doing these distributions for Linux that you can buy and that take the challenge away from you that you have to build your own operating system out of all the pieces. The same is happening for RISC-V. So you have the big incumbents, microcontroller, microprocessor architectures that are in use today. And then you had this Berkeley offspring saying, okay, can we, with RISC-V, so 5th generation RISC architectures, can we build an open source hardware? And everyone who wants to help us optimizing that, please work on that. There was a RISC.org founded that moved into Switzerland to show that they are very neutral, so not belonging to any country and any territory IP-wise, which is important in these geopolitical markets now. And then, of course, there is the question, do we need something like a Red Hat for RISC-V? Again, so something that customizes, that then all the market can either buy or use and so on. And this is the activity that we have formed now. So having basically a distribution of RISC-V that we can do and where we can have the low-end, mid-end, high-end costs.
Distribution, maintenance, in a way also creating operating system, right?
Exactly, so basically scaling the efforts because each of us companies could try to do it standalone. Some of us we are working on RISC-V for products also internally, but it does not, of course, not make sense to do this all standalone and homebrew for yourself. and not being able to commercially scale, if you can cut the cost by factors when others
I
participate.
mean, what made ARM successful wasn't just about chip architecture. In fact, I would argue that chip architecture was okay, but it was ecosystem that was brilliant.
Yes.
So you got all the drivers and other configurations that enable that whole ecosystem to go. So if you want to use ARM, you can usually go into the market much quicker because you got graphic drivers, you got different things to put it together.
Absolutely.
And RISC-V will have to probably get there, and this is probably one of the things we're trying to accomplish.
So I don't want to create a wrong picture here. I mean, ARM is of course still far ahead and a very good benchmark there. And we are using ARM, and we are happy with that, and that all works.
I know you, all your 32-bit architecture is based on that,
No way, that does not make sense to say we are shifting now a direction, that not. But there is just another alternative, an open source alternative coming up that you can use where it fits and where it product-wise makes sense. And this ecosystem, this open source ecosystem is moving at an enormous speed at the moment because also the Asian customers are big time pushing for that because they want to have independent IP and not later a nation being able to say, you are violating our export regulations, you have too much of our IP in the product, you are not allowed to ship. That is a fear in the market. This is why a lot of players look into open source, try to bring that ecosystem forward, but as said, I mean, this is not coming for free, and it's also not...
You know, it'll also take time.
Exactly.
Yeah, it'll take time. Yes. But it is a very interesting new approach and open approach. It should reduce the barrier of entry for innovation because it is available for everybody.
Yes, I mean, that's maybe a very, very important point, available for everyone. Therefore, also smaller student, university type of spring up startup companies have access to that technology, which requires, again, that we don't rest on our laurels and that we are not in denial because, I mean, in 3, 4, 5 years from now, I have to compete against those guys also as a big semiconductor company. So I need to acquire that technology. I need to have these degrees of freedom. And it's great that I can use basically the different tools on my workbench from all the vendors. Yeah.
Very exciting. I mean, obviously, we talked about the importance of collaboration in ADAS and of course, the new approach that requires also open source approach as well. So collaboration is a key message here as we're trying to make an innovation. What are some other messages, Lars, you have for aspiring people that want to be like you or leaders in corporations in a technology industry?
Well, collaboration, cooperation, of course, comes at some point in time. But what you have to have is curiosity. You have to try to understand what you have in front of you, because otherwise we are stuck in this 2018 dreams. Next year, all cars will be driven by AI, and at that moment, you have to ask yourself: do I understand that? Can I explain it to myself? And can I explain it to my parents? Yeah, maybe that's a good exercise, because if it is just super complicated and some magic somehow happens, it's usually not working. But if you are curious, you understand the stuff, and then you are open for collaboration, then you can bring innovation.
You can move the mountain.
Exactly, but you have to understand what you have in front of you, because otherwise you're a victim to all sorts of, sorry for the wording, bullshit bingo, yeah?
Let's talk about one more very important subject in the perspective of consumer, right? Because they are looking at all these automation, new IoT connectivity and others, which supposedly give them convenience and better experience. But people do worry about safety of what they don't see, security. So tell us about what you guys are working on.
What I would say is for all of these devices, so we want to build the world that anticipates and automates. Yeah? Today I have the world, the on-demand world. I need a pizza, I order a pizza on my mobile phone. I need an Uber, I order an Uber on my mobile phone. So on demand, I press a button and I have it. Yeah. The next decade will be this world that anticipates and automates. So little devices around me take tasks. My smart thermostat, Lars is coming home, it knows where Lars is, and then I climatize the house given the weather forecast. So you sense your environment, you connect to big databases in the cloud, and then you think of a smart advice, and that smart advice gets moved to the arms and legs of your little robot. So sense, think, connect, act. And all of that never comes into existence when you cannot trust the devices.
Exactly.
Because for this new market, you have to take your responsibility and have to move it to a little robot. Yeah. And if you don't trust that robot, and if that robot creates even commercial or physical damage, you are not buying these devices and you're even legislating against it and so on. So, and how do you build trust in devices? Okay, so in techie language, that means you have to have safety. So these devices never, ever fail. And if they fail, they come to a safe state or repair themselves. This is the famous functional safety. And these devices never, ever must be abused by outsiders to turn against you. Yes. So they must not be hacked. So safety and security are next to sense, think, connect, act. These two topics that we as an industry have to master, these 6 areas are the things that we need for these devices in the world that anticipates and automates. And this is why we are pumping so much energy into conferences like this autonomous year, into robot discussions and so on.
And secure encryption, hardwired.
Post-quantum cryptography, how do you secure yourself in, against brute force hacking?
Because you know bad guys will try to use your weakest point to come in. And IoT is a great example, right?
Absolutely. And I mean, this is true for your banking cards, this is true for your passport, and we have a huge industry. Also, we inside the company to build those products, surveillance systems for IoT devices, if you want, home alarm systems for IoT devices and so on. So that is a huge industry. This is value capture for us, but it is an absolute must-have requirement because otherwise this new world that anticipates and automates will never come.
Last question for you. How are you using AI in your company?
Big time, but I have to explain it a little bit because we are not the ones to use and to fuel cloud-based AI, like NVIDIA is doing that in the big data centers for the ChatGPTs of this world. So these big models we are not using. But what we are using is, of course, for the smart connected little robots, we try to make them better with AI and machine learning. And what that means is for your hearing aids, having AI accelerators to have a better reception what you're hearing, for language models, for your smart speakers, for your front door camera to understand whether there is a tree moving in the wind or a person standing in front of the door. And only if there is a person, I send you a message to your mobile phone and not 600 pictures of that tree on a windy day. These are the things that we are doing. Better detection, I would call that. So not highly emotional, highly autonomous systems, but superior detection, classification of objects and so on. This is where NXP is super active. We have own AI accelerators and own tool chains for that, with safety and security for our different markets. And we are even award-winning in those areas. But they are, of course, not creating the same amount of press and PR like these big generative AI systems.
You are making things work.
Yes.
On the edge.
Yes, exactly. And in a failure-free way. And that is basically what AI helps us big time every day today in all our solutions.
Well, Lars, I really appreciate your time today. And we have a common mission for doing something good, for Tech for Good, which I really appreciate. But also really appreciate you joining your time to share your experience in NXP and what you guys are doing to improve in an era of exciting ADAS, autonomous, and AI time.